Hello everyone. Today we are going to see about the introduction of data abstraction, which is the third chapter of data analysis and visualization. And I am Muthuraman doing my post-graduation in aerospace domain. We have a lot of examples related to aerospace, and without wasting much time, let's delve into the presentation. As you can see in the image, there is a variety of colored chickpeas in a basket, and the child is trying to sort those colored chickpeas in six various colors. The process of sorting the data in six different types is called as data abstraction, which is the theme of our topic. Data abstraction is the third unit of data analytics and visualization. What we are going to see in data abstraction are task abstraction, action, query, produce, and search. This presentation we will see about what is shown called as data abstraction, and then what are the data and data complexities involved in data visualization. What are the components of data which we call as data sets, attributes, spatial fields, and ordering orientations. Why the user need to do this for data abstraction, how the data abstraction is being performed, and then we will see about task abstraction, what the user is looking at, and whether the task abstraction is a subset of data abstraction or not. Then we will see about targets and actions. Actions are of four types: search, query, reduce, and analyze. We will see about the four types, and then we will go into how is it shown, which we call it as data visualization and interpretation. This is done by looking into targets, and then we will see a summary of all the slides. Data is found everywhere. Data is always unstructured, and humans use this data to take decisions. So data is any source of information that are represented in any form. Abstract refers to the summary or the concatenated version of a large amount of information or many types of informations. From these two, we can say what this data and abstraction is. Data and abstraction refers to simplifying complex data structures by representing them in a more organized and understandable manner, which allows the user to focus on essentials, while hiding the unnecessary details. That is what called as data abstraction. And data abstraction in visualization means graphically representing those abstracted data in visual forms. Commonly, data abstraction takes data in three levels: physical level, logical level, and visual or view level. All the unstructured and unprocessed data that are in recorded formats are called as physical level data. Those data that are just recorded in our computers can be an example for physical level. And those data that are processed for a specific purpose, like summary of a paper, tables, flowchart of a particular action, can be called as logical level. And the image shows the table, which is an example of logical level. And all those processed data that are represented in a visual form to get a clear idea of the data to perform a specific action and purpose. Those type of data are called as visual or view level, and this visual or view level has many divisions that is based on the end user's perspective. And depending upon the customer, this visual or view level changes. Data is complex in nature. The complexity of a data can be understood by organizing the data, and organizing the data can be done by knowing the features of data. How to understand those features? There are three levels of data, but those three levels have the same type of features, and those features would be data types, data sets, attributes, data files, and
ordering orientations. Based on type of representations, there are three levels of data. Text, all those informations in documents, emojis, messages, everything comes under text. Audios, those are recorded, and those are noise types, and music comes under this audio, and videos, images, diagram, videos, all comes under videos section, and this image will be considered as a video with no audio. Data are represented in three forms: text, audio, and video. All those data represented have four basic components, and to understand those four basic components, which are called as items, elements, attributes, and links, we have an example of paragraph and a table. And in this example, we will see the S number, load, stress, strain, modulus of velocity. These are called as elements. And the first row, second row, third row, all those rows specify a particular feature or particular measurements, right? Those things we call it as item. And the link between stress and strain is modulus of velocity. It is a component of data. And then the position of each and every information, each and every cell, we will call it as grid. That is another component of data. So the four components of data are attributes, items, position, and links. Here you can see all those blue colored data which we have presented in paragraph 2 are attributes, and items is all about the red highlighted data. It's all about data or the title of the paragraph. We can say it as a title of a paragraph, or the main content can be explained, which is in two or three words. Is items, and grid explains the position of each and every item or an attribute or a linked data, and the links would be an output of what we are talking. Here they are telling about what are the aspects of this designs. Okay, so the output of this data would be some useful used to split data sets apart from general and useful pieces, right? That's the link between in this paragraph, right? Those are the four components of data. Data set types in visualization. Normally, the data set types in visualization are of five, but we will see only four: tables, networks, geometry, and fields. The last type would be clusters. The table form of information will all commonly we have seen it. It's in Excel sheets, rows, column, attributes, and items. And if the table, if there are a large number of sheets of, then we will call it as a multidimensional table. Networks is all about graph theory, node and links, interconnected with each other. All those things comes under networks, and in networks we can say some structured tree diagrams or tree maps or unstructured hierarchy types. Those are all forms of networks. And fields would be continuous form of data. A best example would be having the earth being positioned in the form of grids that are called as fields. And another example would be our data storage ROM. This 936 or 1 TB hard disk or 500 GB memory, how they are getting allocated, those are considered as fields. And the fifth type would be what I told as clusters. Clusters would be all the combination of data, and this cluster depends upon the data. So there are various types of clusters, and we cannot comprehend, or we cannot commonly categorize these clusters. So I have skipped it. Technical complexities involved in data abstraction would be data availability. Some data should be independent of time. They are offline data. Those data would be already recorded somewhere and being used. Such type of data can be called as static. And some would be real-time data. They are recorded online. Those data are dynamic data. Ordering directions. Some data would be ordered in a sequential way, one after another, or some been diverging within a certain range, those type of data should be there. Or it has been a cyclic way, like a production process or a manufacturing process of a single component to assembly, or a germination of a seed. Such type of things can be considered cyclic. And attribute types. Normally, this attribute types is of two types: categorical and quantitative. In categorical, there are two types: nominal and ordinal. In nominal in the sense those data can never be related with each other, like this plus, circle, square, triangle. Those things can never be categorized or can never be ordered or ranked. Those are different types of data, but all those types can be considered as a can be categorized into a single idea. So those type of data are called as nominal or category of data. And another type of category of data would be ordinal. Ordinal all data in the form of that can be ranked or called as ordered, and it can also be quantitative too. Some data are measured in the form of temperature, pressure, density. Those things can be quantitative. So data are having this many complexities. There are also understandable perspective complexities involved in data abstraction. Those complexities are called as semantic and lexical confusions. For example, the doctor saying an engineering student to eat mixed nuts every day. Doctor knows edible nuts and engineer knows gears, gear nuts, or something like that. And woodcutter says that ask the doctor to use hacksaw to cut the bat into two halves. Woodcutter knows normal bat and doctor knows animal bat. There would be confusion. Hotel server says chicken is being cooked and it is ready to eat. Instead of the chicken, if I am putting some other name of a person like me, my name, hotel server says Mutram is ready to eat. Is Muthu is ready to eat? No. Ashwini said her friend got duck in the game. She didn't get real duck. In terms of game, it means she got out. That's the difference. So, lexical and semantic confusion is a prime problem in abstraction. And semantic means real world meaning. Lexical means linguistic data representation. Semantic means real world meaning. Lexical focuses on linguistic data representation through words, labels, symbol, and numbers. Both are crucial for data abstraction to be done in a comprehend and an easy way. Here is an example of semantic and lexical confusions. For example, for a link type of data like road, friendship, hierarchy. In lexical way, roads on Coimbatore highways are very clear. Sarah is my friend. Lexical. Normally, the meaning of road is road, the common road which we are saying. Sarah is my friend. Friend. The word friend has the common meaning. And here, in semantic side, if you say prayer acts as a road of salvation, the road is being used as a metaphor here. Friendship acts as a compass towards happiness. Compass is being used as a metaphor. Or simile. We will call it a simile or metaphor. I don't know in English, but we will. That's the real world meaning would be changed. In terms of words, company name would be Johnson and Johnson and Co. In lexical, there would be the .co would change the word, and then Inium or Delhi. But in terms of semantic, Apple is the second richest company in the world. The word is Apple is a fruit, but it is being used here as a company name. So it's a difference. Number, date of a month, age, or kilometers. I have already told that lexical data would be represented in the form of numbers, symbols. Okay, so kilometer per hour denotes it's a lexical type of word, and this thing can be, if in terms of semantic it we take now December 13 to December 23, December 13 comma 2023, 2023 doesn't have any significance. Like it's just a number, but it is written after December 13, so it has the meaning. It's a year. He's around 24. It's meaning age. Above come by 2. He says at morning, then it's around 2 p.m. So that's the meaning. These numbers alone represents the meaning. Such type of confusions are common in doing data abstraction. So why people need data in a generic form? Generic form in the sense general form. Why people need? Let's say let's go to a doctor and get some receipt and come. If the doctor's prescription can never be understood by common people. When my mom says, "Do you know him?" She's your grandmother's sister's young brother's son's only daughter. In terms of blood relationship, I am zero. I can never understand. It takes too much time to understand it. Understand it. What's the moral we can understand is certain people can only understand certain things. Everyone cannot understand everything. So data need to be given in a generic form to be understood by everyone. And that's why data is can be abstracted in a generic form specified to the requirement and the understanding level. Okay. All those unorganized or collected data which are represented in a specific form should be converted into the people which who are going to use it. He can be a doctor or a policeman or some sweeper or chef, nurse or some constructor or common people. Anyone who can be. Four major operations involved in data abstraction. First operation would be translating data from a domain-specific language to a generic visualization language. Second would be identifying dataset attribute types. Third would be identifying cardinality. Cardinality means it's all about understanding the data. How many items are present inside the data? Whenever our SAG gives some stock CSV files, first thing we will see is how many columns of data is being there. And the next thing is outlier presence. Is there any singularity inside the data given or in the provided data? Or how many columns are there? And the values of each and every column, like the range of values. And the uniqueness of data is the data is being repeated again and again. Then we should sort it out. We should organize those data. These are all considered as cardinality of data. So identifying coordinate is being done. And the fourth point would be transfer data. Consider whether to transfer it. If the information provided is not enough, then the data need to be recorded again. Or if the data has some errors, then those data should be rectified. Based on it, we should take the fourth decision. Those are the four operations involved in data abstraction. Now we all become an expert of data abstraction. As we have seen the operations to do data abstraction, we all have become an experts of data abstraction. We will go with an activity of a table of data. In this table, as you can see, there are 10 people, and those 10 people are buying shirts from a particular place, and then there is some data called as favorite fruit, some attribute, and those data is also being given. And what's the thing we have to do? We have to identify quantitative, categorical, and ordinal variables, ordinal attributes. And then we need to, as an expert of data abstraction, we need to perform the four operations. We will do it. First thing, we will identify those quantitative, categorical, and ordinal. And as you can see here, all those data that are being given in 1, 2, 3, 4, 5, 6. These are called as items we have seen. Those things are called as nominal data or categorical types. Okay, categorical nominal data, and all those data, the names and items are all categorical. Both are categorical and nominal. Okay, and they are specific for the purpose. This thing, any name is being repeated 2 times, so we can never be say it as nominal. So it's just a categorical type of data. And then is cost is all of numbers, so it's called as quantitative data. And SS, MLL, there is some repetition, also there is some relation between each other. This all states about the size of the shirt, so those are called as ordinal data. Apple, pear, all are fruits. That's the relationship. Those are ordinal data. As an expert of data extraction, you will perform those four operations. Okay, those four operations. And for performing the first operation, you need to know the subject, purpose, and the target. Subject is shirt sales among various customers. Purpose is understand type of customer and cost they are willing to spend for each shirt. Targeted host in the sense end user who are going to use this data is marketing people. This subject, purpose, and target. Without having a clear idea of these three, we can never do this data abstraction process. We can never do this first operation of data abstraction. Then, after doing this first operation, we are going to see identify data sets and attributes. What are those data sets involved? Name, shirt size, cost. There is was another attribute too, but it is not required to understand the subject. So it's being removed. It's not required. And then we are trying to see identify cardinality. As you can see, the shirt size is from S, L, and M. These are the common sizes. And the cost would be from 348. The least cost would be 380 and the highest cost would be 1442. So we have identified the cardinality and the total number of data were 10, but the ME was repeated two times, so I have made it as 9 data. Okay, we have identified and transformed data. Yeah, I have transformed the data. How I have transformed the data? Seeing those data, you can understand, you can see the font size has been changed. First thing you can see. Then the numbers are being right centered and the letters and the words are being left centered. Okay, and then the unnecessary data, which was fruit's favorite fruit, that was not required for this subject, right? That has been omitted. And then what has seen is the names are being arranged in ascending order, and the cost spent is being highlighted. This thing which we has been highlighted using the Excel sheet. And in this color, we can see the 1300 and 2400 and 2420. Those are being in green color because for marketing people, these customers should be seen in a prior way. And those people who are buying shirts for a small amount, those people will be neglected. As per the requirement of the targeted end users, the data abstraction should be done and the transformation of data has been done. This is what called as data abstraction. Okay, where data is there, so everywhere data abstraction is also being happened. What are the applications of data abstraction in aerospace domain? First thing would be complex data management. Collecting all the data and managing those data is really tedious, and this is done using data abstraction method. Next would be real-time data collection and summarization. For satellite data about weather forecast, climatic conditions, space exploration, solar radiation, and cosmic energy, those types of data are collected in real time and are summarized within a period of time fastly. Those things are an application of data abstraction. Third application would be streamlined communication interface for 3DM. 3DM stands for device driven decision making. In ATC centers, we use this data abstraction method to sort those problems involved in landing the aircrafts and take off the aircrafts. Another application, resource utilization, is another application of data abstraction. Understanding the stress, strain, aerodynamics of the flight, we are adapting the flight to two different types of materials, which provides lightness to the aircraft to fly easily. This is an application for data abstraction and reducing the efforts of pilot, crew members, and ATC center as well as the passengers. It's also an application involved conditional health checking and data sorting based upon the health of the material, health of the aircraft. It doesn't mean only the aircraft, it also means the pilot's health, engine's health, fuel, and the passenger's health. Everything can be categorized, and based on those data, when we are dealing with those data abstraction, will happen. And another would be training and simulation. Different parameters need to be checked for different situations and they must be organized. The last example would be data security and privacy. Just by encoding and decoding the informations, those data are secured. And this thing is very important for aerospace domain. This is all done using data abstraction. Now we will have another example. Patience for listening till now. We will finish this session by this last example. I have abstracted the data about for landing rover on the moon. Each and every end user needs different type of abstracted data. For the flight director, single word information is enough, like preparation, descent, landing fuel check. All are positive or negative is more than enough for them. For control room operator, flight performances, navigation team, rover's trajectory, engineers team, unabstracted sensor readings are required. With those data, they can find the abnormality in the data. Uh, they read those data and then as pilots are astronauts, they need the rover key controls and visuals of the lunar surfaces, simplified telemetric data, those data they require. And for communication specialists, communication links, signal strength, and telemetry, all about the communication health related data they require. Safety officers are about mission critical elements such as fuel reserves, power levels, and key sensor readings, those data they require. For public relation team, it's all about the mission stages, what are the milestones they have achieved, and the exciting images captured by the rover cameras. How tedious the work is in rocket launch station. Okay, these are all the data required, and with this session, I am finishing my presentation here. Thank you for listening till now.